Good evening, and welcome back to another night beneath the stars. Tonight we leave roads and ruins and written chronicles behind and step out under the open sky. We will follow Orion as he rises over winter fields, stand with the Great Bear as it wheels around the northern pole, and watch the fragile curve of the Southern Cross above distant seas. We will listen to the stories that named them, and we will learn what the stars themselves reveal, how they live, how they burn, and how their light crosses impossible distances to reach your eyes. As always, I would love to know where in the world you are listening from, and if the sky above you is cloudy or clear. If you enjoy these stories, please like this video and subscribe. It is the easiest way to support this channel, and it helps these quiet journeys through the night sky reach more sleepless travelers. Thank you for keeping me company under the stars tonight. Now, if you wish, close your eyes, relax, and let us begin. On some forgotten night, long before cities or calendars, before anyone carved a story into stone, someone looked up and refused to see only chaos. The fire was dying at the center of a small camp. Shadows breathed along the ground. Above, the sky was a black sea, and in that sea hung a scatter of lights. They could have been sparks, could have been eyes, could have been nothing. But the watcher began to join them. 3 bright points stood in a tidy row, almost perfect. A little above them lay a crooked square of light. To one side ran a pale river, the Milky Way stretching from horizon to horizon. The mind that had learned to see the curve of an antler and the edge of a footprint now traced something greater. The 3 stars became a belt. The square became a body. The river became a road. A hunter took shape above the world, striding across the darkness with an invisible bow in his hand. No one wrote that moment down. There were no names yet for those lights, no Greek or Latin, no language that anyone alive would recognize, but the habit that began there never ended. Night after night, century after century, people stood under the sky and drew lines between the stars. They told each other what they saw. The stories hardened into memory. Memory hardened into tradition. In time, tradition became constellations. When you look up now, you inherit all of that. You are not only seeing nuclear furnaces scattered through space, you are seeing the leftovers of ancient campfires and ancient fears and ancient hopes. You are seeing the ghosts of storytellers. The people of Mesopotamia once watched that same sky from the banks of the Tigris and Euphrates. They spoke of a great twins, and a lion, and a scorpion that marched along the path of the Sunday. Egyptians standing beside the Nile took note when certain star groups rose just before dawn, because those risings were tied to the flooding of the river and the turning of the year. Long before anyone spoke of constellations in the way we use the word now, the sky had already become a calendar and a clock and a storybook. Then came the Greeks, and later the Romans, with their own fierce gift for narrative. They borrowed some of the older figures, reshaped others, and wove them into a tapestry of myth that still clings to the stars above the Western world. If you know the names Orion and Andromeda and Cassiopeia, if you can picture a great bear circling the northern pole, you are walking in the footsteps of poets and philosophers who lived more than 2,000 years ago. Imagine for a moment that it is night in an Aegean port town. The air smells of salt and tar and fish. Boats rest on the shingle, their masts like bare trees against the sky. A young sailor lies on his back beside the water, staring upward. He sees a scatter of stars that the elders have told him is a hunter. They call him Orion. In the stories the sailor grew up with, Orion is a giant who can stride through the sea with his head still above the waves. He is brave and proud and perhaps a little too sure of his own strength. He boasts that no beast can defeat him. It is the sort of pride that makes gods curious. The gods send a scorpion. The creature rises from the earth, tail arched, and stings the hunter. The giant falls. Perhaps the sailor has a friend who tells the story with gestures and a grin, making a game of the whole grim business. The details shift from island to island, from mouth to mouth, but the shape is the same. Hunt, pride, fall. The gods, as always, are watching. To honor the hunter and the scorpion, the story says, the gods place them both in the sky. That is why the sailor is told that Orion and Scorpius never share the heavens. When the scorpion rises in the east, the hunter has already fled below the western horizon. When the hunter returns, the scorpion has sunk out of sight. Two characters locked forever in a dance of pursuit and retreat, played out on a stage made of stars. The tale is not just a tale. For the sailor, the pattern of Orion is a sign of the season. When the belt of 3 stars climbs over the horizon just after sunset, winter is on its way. When Orion rides high at midnight, cold weather is in full command. When he sinks toward the west in the early evening, the year is turning again. Story and science are not yet separate things. The myth is also a practical tool. Look higher in that same sky, and you will find a crooked W of light, 5 bright stars bending back and forth. That is Cassiopeia, the queen on her throne, endlessly wheeled around the pole. The Greeks tell that she was vain, proud of her own beauty and that of her daughter, Andromeda. She boasted that they were fairer than the sea nymphs. The nymphs complained to the sea god. A monster rose from the deep to punish the kingdom. To spare her people, Andromeda was chained to a rock beside the water, offered as a sacrifice to the beast. You can almost hear the surf pounding against those rocks in the telling, the chains rattling every time the tide surged. Enter Perseus. He has already gone through one ordeal, facing the Gorgon Medusa, whose gaze can turn living flesh to stone. Armed with a mirrored shield, he tricked her, cut off her head, and now carries that head in a sack at his side. He also rides upon the back of a winged horse, Pegasus, born from the blood of the Gorgon. It is all fantastical and wild, and yet perfectly natural in the logic of myth. Perseus sees the princess, hears her story, and chooses to fight the monster. He descends, draws forth the Gorgon's head, and brandishes it. The beast meets that dead and deadly gaze, and hardens into rock. Andromeda is saved. So the gods give them a reward that has nothing to do with gold or crowns. They place them in the sky. Tonight, if you know where to look, you can still see the entire drama frozen above you. Cassiopeia, the queen, sits on her throne with her sharp W of stars. Cepheus, the king, stands nearby, modest and almost forgotten. Andromeda lies stretched out in a long chain of stars that runs from the royal pair toward the great square of Pegasus. Perseus shines above her, with a flickering star in his hand that some storytellers like to imagine as the blinking eye of Medusa's head. This is not an accident of naming, it is careful design. The storytellers and the stargazers worked together. They wanted you to be able to stand under that sky and see not only isolated points of light, but a complete cast of characters, connected by invisible lines. The northern heavens became a crowded stage. Here a hero and princess and monster, there a bear that never sets. Over there, a swan forever in mid-flight, a lyre held up by an unseen musician, an eagle bearing the thunder of Zeus. In the 2nd century of the Common Era, many of these shapes were gathered and fixed in a more formal way. In the city of Alexandria, a scholar named Ptolemy compiled a great work on astronomy. In its pages, he listed 48 constellations, with the positions and brightness of more than 1,000 stars. The names he used were Greek and Latin, the same names that echo in our star charts today: Orion, Andromeda, Cassiopeia, Perseus, Ursa Major, the Great Bear, Leo, the Lion, Scorpius, the Scorpion. He did not invent them all. Many were already old when he wrote, rooted in the poetry of Hesiod and the songs of Homer, or inherited from Babylonian sky lore that was ancient even then. But by writing them down, by measuring them and storing their positions on a careful grid, he did something that storytellers alone could not do. He began to pin the tapestry of the sky to a frame that would last. It is tempting to think of this as the moment when science arrived and story was pushed aside. It was not that simple. Ptolemy was as much heir to the myths as any poet. He did not strip the sky of its heroes and monsters. He preserved them. In his book, each constellation is both a figure from legend and a map of specific stars. The hunter is also a pattern of coordinates. The queen on her throne is also a cluster of measured points. Imagine that same sailor who once lay on the beach, now older, with grey in his hair, listening in a city square as a librarian from the Great Library of Alexandria explains the new work. The librarian speaks of declination and right ascension, of the way the sky can be sliced into imaginary circles and lines, much like the Earth. He points at a chart where the constellations are drawn in ink, each star given a symbol to show its brightness. Yet when he looks up later that night, the sailor still sees the same hunter and the same chained princess. The vocabulary has grown richer, not poorer. In the fields far from the cities, farmers still rely on older wisdom. There is a time of year when a particular star rises just before the sun, appearing briefly in the dawn before it is lost in the growing light. This is called a heliacal rising, and it has always been a subtle signal. For some, the heliacal rising of a bright star marks the coming of floods, or the moment to sow grain, or the approach of stormy weather at sea. The detailed lists of astronomers and the practical lore of farmers overlap in the constellations. Both need to know when certain star groups will appear and where. In a world without electric light, the sky is not a distant ornament. It is the roof of the world, always watched. Shepherds know the slow rotation of the Great Bear around the pole. Sailors learn that the bear never sinks below the horizon at their latitude, and that the faint star on the end of the little bear's tail, Polaris, sits close to the North Celestial Pole. If they can find that star, they can find North. If they can find North, they can find home. So the bear becomes more than a story about a woman changed into an animal and sent into the sky to escape the wrath of a god. It is also a guide, a fixed point in a shifting world. This is the secret at the heart of the constellations. They are made of two kinds of line. One is the invisible stitch that joins star to star, making patterns that no one would see if they were not told to look. The other is the line that runs from the human eye and mind back to those stars. Meaning is poured along that line. Fear, hope, pride, curiosity. All of it travels upward and lodges there among the points of light. The sciences of later ages will show that the stars in a given constellation are not close to one another in space. They are scattered at very different distances, some hundreds of light years away, some thousands, and they drift through the galaxy on their own paths. The figures we see are illusions of perspective, like shapes in clouds. Over vast stretches of time they will change. The belt of Orion will stretch or twist as its stars move. The W of Cassiopeia will warp and open. The Great Bear will grow unrecognizable. But none of that diminishes the force of the stories or the usefulness of the patterns. A constellation is both something invented and something discovered. Invented because no line actually ties one star to another. Discovered because there is something very real in the way our minds respond to the sky, in the way those specific groups of stars catch our attention and hold it. Again and again, across different cultures and centuries, people who never spoke a word to one another chose many of the same bright groupings. A hunter with a belt and a raised arm, a lion, a scorpion, a great animal that circles the pole. In the end, the tapestry above you is woven from 3 threads. The first is myth, with its quarrelsome gods and brave or foolish heroes. The second is observation, the careful watching of risings and settings, of the way some stars never set while others vanish for part of the year. The third is measurement, the quiet work of scholars who count and compare and write things down. Together they have turned the sky into something we can read. Tonight, when you step outside and lift your eyes, you can choose which of those threads to follow. You can imagine yourself by a fire on a long vanished plain, tracing your first hunter. You can stand beside a Greek harbor and see a queen and a princess and a hero arranged above the water. You can stroll through the halls of Alexandria and watch a scribe ink the outline of a bear onto parchment, all while the same stars continue to burn overhead, unchanged in their essence, yet endlessly remade in our imagination. The mountain held the observatory like a secret. All around it, the land fell away into darkness, into valleys where the last village lights were already fading, into forests that had no interest in what went on above their own tallest branches. Up here, the night belonged to the sky alone. The dome was open, a black mouth turned toward the stars. Inside, under the dim red glow of the control room, a young astronomer sat before a bank of screens. At a glance, those screens showed nothing but scattered points, white on black, no different in spirit from the view a shepherd might have had beside a fire 5,000 years before. But the astronomer knew there was another layer laid on top of that simple darkness. A net of invisible lines that only humans could see. On one screen, a chart glowed. It looked less like a night sky and more like a strange atlas. Lines crisscrossed the blackness, slicing it into irregular shapes. Each shape had a name written in careful Latin letters: Orion, Taurus, Leo, Scorpius, Crux. There were 88 in all, each one a parcel of sky with measured borders. Once, constellations were simply pictures: a hunter here, a lion there, a swan with a long neck stretched out beside a harp. Their edges were hazy, their territories uncertain. One storyteller might draw Orion larger, another smaller. Where exactly did his raised arm end and the next constellation begin? No one could say, and for most of human history, no one needed to. But as astronomy grew from naked eye watching into a precise science of measurement, that blur at the edges became a problem. Telescopes revealed not just bright stars, but faint ones, clusters, nebulae, galaxies. Each new point of light needed an address. It was no longer enough to say, for example, that a comet passed through the shoulders of the hunter. You needed to know its exact position so that another astronomer on another mountain could point their instrument to the same place and find the same wandering smudge. So the sky was treated as if it were a globe surrounding the Earth, a hollow sphere whose inner surface held every star. That sphere could be marked with lines, just as cartographers mark longitudes and latitudes on a map of the world. A celestial equator could be drawn as the projection of Earth's own equator into the sky. Poles could be defined where the axis of the planet's rotation pierced that sphere. Circles of constant declination and arcs of equal right ascension could be traced so that any point in the sky could be defined by two numbers. The more precise the measurements became, the more pressing another question grew. Where do the constellations live in this scheme? If the sky is a coordinate grid with every point labeled, then a constellation cannot only be a picture made of a few bright dots. It must be a region, a tract of sky whose borders can be described in numbers. In the 20th century, when astronomers from many nations gathered under the title of the International Astronomical Union, they tackled that question directly. They took the old figures inherited from Ptolemy and the later star makers, added the newer constellations invented by observers of the southern sky during the Age of Exploration, and pinned them all to a single plan. The result was a list of 88 official constellations. Every patch of sky belongs to one of them. There are no gaps and no overlaps. On the astronomer's screen, those decisions lived as thin white lines dividing the black. The outline of Orion no longer depended on a poet's memory. It had become a chain of right ascension and declination values. Where old star charts had drawn the hunter with muscular shoulders and a cloak, modern charts showed a polygon labeled with a Latin name. Within that polygon, every star, every nebula, every galaxy is said to be in Orion. Outside, they are not. It sounds cold, perhaps. A hunter reduced to coordinates. A queen on a throne turned into a sharp-edged field with corners at precise angles from the celestial equator. Yet this act of drawing borders did not erase the stories. It preserved them and made them useful to a new age. When an astronomer catalogues a red giant star as Alpha Orionis, they are saying two things at once. The Greek letter marks it as one of the brighter stars in its group. The Latin name, in its grammatical form, tells you that this star lives in the territory of Orion. The hunter still owns his stars, even if they now march under the discipline of physics and mathematics. The system of naming within constellations grew over centuries. In the early 17th century, a German lawyer and astronomer named Johann Bayer produced a star atlas. In it, he introduced a convention that is still used today. For each constellation, he assigned Greek letters to the stars, usually in order of brightness. Alpha for the brightest, Beta for the next, and so on. So we have Alpha Centauri, Alpha Lyrae, Alpha Orionis. Later, an English astronomer named John Flamsteed added another approach. He numbered stars in each constellation in the order of their right ascension, from west to east, and then attached the Latin name of the constellation. That is why you may meet a star called 58 Orionis or 16 Cygni. There are older names as well, many of them from Arabic, carried through the medieval period when much of the finest astronomical work was done in the Islamic world. Betelgeuse, Rigel, Altair, Deneb, Aldebaran, all echo those centuries. In a single star name, the threads cross. The ancient myth that gave the constellation its shape, the medieval astronomers who traced and named individual lights, the modern institutions that fixed everything into a shared system. The young astronomer in the dome could call up tables where all of this sat together, a column of Greek letters, a column of Flamsteed numbers, a column of traditional names with roots in many languages, a column of precise coordinates. When they typed in the catalog number of a target, the telescope slewed with a soft mechanical sigh, turning from one derived location to another, blind and confident. There is a kind of magic in that. Not the wild magic of heroes and sea monsters, but a slower, colder enchantment. You take a sky that looks like a random scattering of lights, and you impose order on it. You impose not only straight lines and labeled regions, but time. To measure a star's coordinates is to fix where that star appears at a particular date, because the sky is not truly fixed. The Earth does not spin like a perfectly balanced top. Its axis wobbles over long ages, tracing a slow circle in the sky. This motion, called precession, shifts the position of the celestial poles and the celestial equator. Over thousands of years, the coordinates of all stars change. Polaris has not always been the pole star and will not remain so. Ancient Egyptian temple shafts that once framed a particular bright star as it rose no longer do so, because the sky has glided past their stone sites. Proper motion adds another layer. Each star is not a pin stuck in a black ceiling. It is a sun in its own right, moving through the galaxy with its own velocity. Most are so distant that their motion across our sky is slow, measured by astronomers in arc seconds per year, tiny shuffles that demand patient instruments. Over human lifetimes, they scarcely matter. Over spans of many thousands of years, they redraw the constellations. Simulations can show this. On one of the screens in the observatory, the astronomer could run a program that accelerates time. In a few seconds, the belt of Orion stretches. The bright red shoulder star drifts. The Great Bear loses the familiar ladle pattern that people in northern lands have used as a guide forever. Cassiopeia's sharp W softens and then twists into something stranger. The sky, which feels so eternal when you glance up on a cold night, betrays its true nature as a dynamic, changing system. Constellations, then, are snapshots. They are the patterns that human beings happen to see during a particular era of their own history. The Greek fisherman and the modern astronomer agree on the shape of Orion because they live within a relatively thin slice of time, move far forward or backward, and a different pattern would present itself. The fact that our minds insist on seeing hunters and bears and swans, even as the dots move, is a reminder that the shapes are in us as much as in the stars. Within that great moving tapestry, there are also smaller figures that do not rise to the level of official constellations. These are asterisms. They are familiar to casual stargazers and rarely troubled by committees or formal borders. The Big Dipper, for example, is one of the most famous patterns in the northern sky. 7 bright stars bent into the shape of a ladle. It is not a constellation in its own right, but part of the larger body of Ursa Major, the Great Bear. The Summer Triangle is another, composed of 3 bright stars from 3 different constellations: Vega in Lyra, Deneb in Cygnus, and Altair in Aquila. To the eye, they make a striking triangle on summer nights. To the astronomer, they belong to different parcels of the sky. Asterisms show that the human tendency to trace lines does not care about official maps. People see what catches their gaze. Yet the official map remains essential. If you are writing a paper on a newly discovered exoplanet around a sun-like star, you cannot say that it lives in the handle of the Big Dipper. You must say that it lies in Ursa Major at such and such a right ascension and declination, and perhaps that the host star is known as something like HIP followed by a long number. The language of science is less charming, perhaps, but far more exact. All of this may give the impression that the constellations have become merely technical designations, that the ancient figures are now little more than labels on a grid, but this is not quite true. In practice, astronomers still speak of them with a certain fondness. The novice observer is taught first to find the bright asterisms and constellations with their naked eyes. The bowl of the Big Dipper, the M shape of Cassiopeia, the cross of Cygnus, the belt and sword of Orion. Only once those are familiar does the student learn to read the coordinatized charts. The maps of the sky are stored in memory as overlapping layers, one poetic, one numerical. Consider a cold autumn night at the observatory. A visiting student stands outside with a printed star chart in her hands. The chart shows the constellations as thin outlines, their Latin names printed in small capitals, the stars plotted as dots of different sizes. Beside her, an older astronomer points with a gloved hand. There is the Andromeda constellation, a long chain of stars that runs away from Cassiopeia. The fuzz you see with your unaided eye, near its middle, is not a star at all, but an entire galaxy, the Andromeda Galaxy, a vast island of light far beyond our own. Over here is Perseus. Over there, spanning the sky, is Pegasus, with the great square that marks his body. The student begins to match the chart to the sky, tilting the paper so that it lines up with the stars. Once the pattern clicks, something changes in her perception. The sky stops being a random scatter and becomes a structured thing. Back inside, at the control console, that same student might be taught another lesson. The mentor calls up the coordinate grid, an invisible lattice that runs behind the constellations. Lines of equal declination run parallel to the celestial equator, which itself is angled relative to the ecliptic, the path the sun traces through the sky over the course of a year. Lines of right ascension radiate out from the point defined as 0, sweeping eastward like slices of an orange. They learn that when you say a star lies at a declination of 30 degrees north and a right ascension of 10 hours, you are giving it a unique address that any telescope anywhere on Earth can use. You are also, quietly, acknowledging the slow march of time, since those coordinates will drift as precession nudges the frame. Catalogues must therefore state which epoch their coordinates refer to, so that future astronomers can account for the difference. The dome above their heads is not a perfect representation of what is on the screen. The screens flatten the sphere and distort some regions just as maps of the Earth do. A constellation near the pole looks stretched or compressed, depending on the projection. A constellation near the celestial equator looks relatively undistorted. The student eventually understands that any picture of the sky is a compromise between clarity and fidelity. The true sky is a vault. Any map is a peeled skin laid flat. Through all of this, the names of the constellations whisper their older meanings. The student can recite them in order, perhaps, as many beginners are encouraged to do. A row of Latin names with personalities behind them. Some are noble, some are humble. Canis Major and Canis Minor, the greater and lesser dog, companions to Orion. Hydra, the water serpent. Corvus, the crow. Sextans, named after an instrument. Telescopium, another nod to tools. The ancient habit of naming shapes after animals and heroes has been joined by the more recent habit of naming them after devices of observation, a neat little piece of self-reference written into the sky. The 88 constellations are therefore not only a patchwork of stories, but a record of the development of astronomy itself. The ones that ring the northern sky with their royal family and monsters mostly come from Greek stories recorded by Ptolemy. The constellations of the deep southern sky, visible only from lands explored by European sailors from the 15th century onward, include creatures and instruments familiar to that age. Dorado, the swordfish. Volans, the flying fish. Microscopium, the microscope. If you were to strip away every line and every name from the sky, leaving only the cold white fire, the physics would not change. Hydrogen would still fuse into helium. Giant stars would still swell and throw off gas into space. Gravity would still draw matter into dense clusters, and tidal forces would still twist galaxies into peculiar shapes. Yet something would be lost, because human meaning would be gone. The constellations are how we attached ourselves to that indifferent immensity. The astronomer on the mountain knows this, though perhaps they do not say it often. They speak of hours and degrees, of spectral classes and radial velocities. They log measurements, calibrate instruments, write code. Yet on some nights, when the air is very clear and the work is briefly done, they step outside and look up without any screen between. Then the hunter and the queen and the great bear emerge from the darkness once more, not as data points but as presences. The observatory fades away. The mountain becomes only a high place under an ancient sky. The grid and the stories rest together there. They do not cancel each other out. They make one another possible. Without patterns, the sky would be too overwhelming to grasp. Without measurement, the patterns would remain only charming fictions. Together they let you locate a faint galaxy so dim that you cannot see it at all with the unaided eye, and yet feel that you are finding it along the flank of a lion or in the wing of a swan. This is the true chart of the heavens, a map not only of stars in space, but of minds reaching upward from the dark ground of their own planet. The sky has many rivers and roads, but only one royal highway. It is not marked by signs or lamps. It is not carved into rock or soil. It is traced instead by the wanderings of the sun and the restless glimmer of the planets, a narrow belt around the sky that all of them follow. Long before anyone spoke of galaxies or gravity, people saw that the sun kept to a certain path across the firmament, that the moon and the wandering stars we now call planets stayed close to the same invisible line. They gave that highway a name. The ecliptic. Along that path they set a procession of figures, a ram with curved horns, a great bull lowering its head, a pair of twins hand in hand, a crab scuttling sideways, a lion that roared from the heart of summer, a girl who poured water, a half man, half horse drawing a bow, a goat with a fish tail, a pair of scales balanced in the dark, a scorpion with its sting raised, a fish that seemed always to be swimming just ahead of the Sunday. Together these became the zodiac, a circle of constellations wrapped around the earth. Picture again the sailor on the Aegean shore, or the farmer standing in a field of ripening grain. The sun has set, and the first bright points are appearing. The band of the zodiac stretches from the west, across the south, and down into the east. To the people of that world, the figures along this band are not just stories. They are signposts on the only road the sun ever takes. As the year turns, the sun seems to pass through each house in turn. The ram heralds spring. The bull presides over planting and growth. The scorpion watches over the time when heat becomes harsh and the year begins its slow slide toward winter. The zodiac is older than the Greek names that cling to it now. In the plains of Mesopotamia, under a different language and a different set of gods, scribes already listed constellations that hugged the path of the Sunday. Clay tablets from Babylon record a sequence of star figures that are recognizably ancestors of the 12 signs that would later be carved into Greek and Roman thought. The two great twins who became Gemini, the lion whose stars we still call Leo, the scorpion that crawled across the summer sky. For those early astronomer priests, the sky was a ledger. Each figure along the zodiacal band marked not only a picture, but a stretch of the year. It was a way to track time, to know when rivers were likely to flood, when certain winds would return, when it was wise to plant barley or set out to sea. When Greek philosophers took up the study of the heavens, they inherited this ring of watchers and translated them into their own stories. The ram became Aries, the heroic animal whose golden fleece would later draw Jason and his crew across the sea. The bull became Taurus, sometimes identified with the white bull, into which Zeus transformed himself to carry off Europa. The twins became Castor and Pollux, brothers whose love for one another was strong enough to overcome death. Look up on a clear spring night, and the story unfolds in slow motion. On the western horizon, the fading ram of Aries sinks as darkness deepens. Above it, the bull of Taurus stands firm, its face marked by the bright red star Aldebaran and the wide V of the Hyades cluster. Near one of its shoulders sparkles the Pleiades, the seven sisters, a small swarm of blue-white stars that inspired stories in many cultures. To one side, the twins of Gemini rise, their heads marked by the pair of bright stars Castor and Pollux. Each of these shapes is a calendar page. In ancient Greece, and in many lands that borrowed its sky lore, people knew that when the sun rose among the stars of Aries, it was the season of spring. When it stood among the stars of Cancer, summer had taken full command. When it approached the stars of Libra, days and nights balanced at the equinox. The wheel of the year was tied to the wheel of the zodiac. Over time, that relationship grew into something more elaborate. The idea took root that the position of the sun against the background of the zodiac at the moment of a person's birth said something about their character and fate. The same thought was applied to the wandering planets, where Mars stood in the lion or the fish, where Venus shone among the scales or the goat, was said to influence the temperament of kings and the fortunes of cities. This was the beginning of what we now call astrology, the attempt to read human stories from the movements of the heavens. Astrology carved the zodiac into an even neater arrangement than the sky itself provides. It took the circle of the ecliptic and divided it into 12 equal sectors, each 30 degrees wide, and assigned each sector the name of one of the zodiac constellations. These sectors are the astrological signs: Aries, Taurus, Gemini, and so on around the ring. The sky, however, has never been quite so tidy. The constellations along the ecliptic are not equal slices. Leo sprawls wider than Cancer. Virgo occupies a large stretch of the path, while Scorpio occupies a modest one. The sun spends many weeks among the stars of Virgo, and only about a week among the stars of Scorpius. Moreover, there is an extra figure on that road, one that the equal division of the astrologers did not admit. Between Scorpius and Sagittarius, there is a man holding a serpent. His name is Ophiuchus, the serpent bearer. The ecliptic passes through his realm as well. If you were to stand under a perfectly transparent sky and watch the sun step from one backdrop of stars to the next over the course of a year, you would see it spend time in 13 constellations, not 12. Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpius, Ophiuchus, Sagittarius, Capricornus, Aquarius, Pisces. For modern astronomers, all 13 are part of the zodiacal belt. When planetary scientists describe a comet that happens to brush past the stars of Ophiuchus, they will say that it is moving through a zodiacal constellation just as surely as if it were passing through the claws of Scorpius. The difference between sky and symbol only grows more striking when you take into account the slow wobble of the Earth. The axis of our planet traces a circle in the sky over a period of roughly 26,000 years. This precession means that the positions of the equinoxes and solstices slide along the ecliptic. At the time when astrological traditions were being set in the classical world, the spring equinox occurred when the sun was in the constellation of Aries. That is why, in astrology, the first sign is associated with the start of the year, with beginnings and fiery energy. Now, after many centuries of precession, the spring equinox occurs when the sun is among the faint stars of Pisces. In a few thousand more years, it will take place in Aquarius. The astrological signs have remained fixed, tied to the seasons in a system called the tropical zodiac. The astronomical constellations have drifted, tied to the actual background of stars. This is why someone who is told they were born under the sign of Leo might find that the sun was in fact passing through Cancer when they entered the world. The mismatch is not a trick. It is a consequence of a moving sky and a tradition that chose to hold its symbolic wheel still. From the perspective of modern science, astrology has failed every careful test placed before it. The positions of planets and the sun against the zodiac have not been shown to shape personality or fate in any reliable way. Yet the zodiac constellations themselves remain deeply important, both culturally and scientifically. They are vivid markers along the ecliptic, and the ecliptic is where much of the interesting action in our solar system takes place. In a good planetarium show, the narrator will often pause the motion of the sky and draw a faint glowing band around the dome. This is the zodiacal belt, they will say. If you watch where the moon wanders night after night, you will see that it never strays far from this band. The same is true of the planets that can be seen with the naked eye: Mercury, Venus, Mars, Jupiter, Saturn. Even the more distant worlds like Uranus and Neptune stay within a modest distance of this celestial road. It is simply the projection of the plane in which the planets orbit the Sunday. For an observer learning the sky, the zodiac gives structure. If you spot a bright point of light among the stars of Leo that was not there a few weeks before, and it does not twinkle, chances are good that you have found a planet. Its presence among the stars of that lion tells you something about its position in its orbit. When astronomers describe the apparent motion of a planet, they still speak in these old terms. A planet in retrograde appears to move backward against the background of the zodiac, like a traveler who turns and retraces their steps along a familiar road. Each zodiac constellation has its own character, not only in myth but in the physical arrangement of its stars. Take Leo, for instance. To the eye, it is marked by a prominent pattern that looks like a backward hook or a question mark. This is the sickle, an asterism whose brightest star is Regulus, the heart of the lion. A hot blue-white star relatively close to us in galactic terms. Behind the visible stars, deep in the field of Leo, lie distant galaxies that only reveal themselves in long exposure photographs. For the astrophysicist, Leo is not only a regal beast, but a window into clusters of galaxies. Scorpius, the scorpion, is one of the most recognizably shaped constellations in the sky. On a clear summer night in low latitudes, you can see its long body and curling tail stretching near the central bulge of the Milky Way. Its brightest star, Antares, glows deep orange, a supergiant star nearing the end of its life. Antares is thousands of times more luminous than the Sun, and so large that if it were placed at the center of our solar system, its surface would extend beyond the orbit of Mars. This is the red heart of the scorpion, pulsing in the heat of summer. Sagittarius, the archer, is a complicated figure in mythology. Sometimes it is a centaur, sometimes just an archer. In the sky, many observers see instead a teapot. A cluster of stars near its center outlines a spout and handle remarkably well. Along the line of that spout lies the center of our galaxy, hidden behind thick clouds of dust and gas. Within that hidden heart resides a supermassive black hole around which the entire Milky Way turns. The archer thus points his arrow toward the very core of our stellar island. Pisces, the fish, is a sprawling constellation with a faint outline that challenges the eye in light-polluted modern cities. In story, it often represents two fish tied by a rope or ribbon, a symbol with roots in both Greek and older mythologies. In the language of astrology, Pisces is associated with dreams and illusions, with deep waters of emotion. In astronomical practice, its most notable role today is as the realm where the sun resides during the vernal equinox, the marker of spring. The phrase Age of Pisces, like Age of Aquarius, arises from this slow drift of the equinox point across the zodiac. Virgo, the maiden, is another wide constellation, often associated with goddesses of grain and harvest. Its brightest star, Spica, is a blue-white giant that also holds significance for navigation and for timekeeping. In ancient times, the rising of Spica just before sunrise was tied to the agricultural calendar in several cultures. In the modern sky, Virgo is home to a vast cluster of galaxies, the Virgo cluster, which has become central to our understanding of the large-scale structure of the cosmos. A handful of apparently random faint smudges in an amateur telescope becomes, for a professional observer, a key to the distribution of thousands of galaxies and the dark matter that binds them. Cancer, the crab, is modest in brightness, but hides a gem in its heart. The beehive cluster, also known as Praesepe, is a swarm of stars that to the naked eye appears as a cloudy patch. Through binoculars, it explodes into dozens of pinpoints. Ancient observers knew it well and used its visibility as a weather sign. Cancer also marks the place on the ecliptic where, in classical times, the sun reached its highest point in the sky at the summer solstice. That is why the line of latitude on Earth where the sun stands overhead at that moment is called the Tropic of Cancer, even though precession has moved the solstice point into Gemini in the actual sky. Capricornus, the sea goat, is a strange hybrid creature. In story, it is often linked to the god Pan, who leaped into the water to escape a monster and half transformed in his panic. To the eye, the constellation is not particularly striking, a faint triangle of stars. Its importance stems mostly from its position. In earlier ages, the winter solstice occurred when the sun lay among its stars, and so the southern counterpart of the Tropic of Cancer is still called the Tropic of Capricorn. These layered meanings, physical and symbolic, show how the zodiac has always been a meeting place. Where mythology sees heroes and animals, astronomy sees hot plasma and changing coordinates. Where astrology draws charts that claim to predict love affairs and political fortunes, science draws plots of planetary positions and uses them to navigate spacecraft. The same ring of constellations supports both kinds of imagination, though only one rests on tested truth. In the observatory on the mountain, the young astronomer sometimes pulls up a program that shows the ecliptic and the zodiac in a simple way. It draws a circle, marks the constellations along it, and shows the positions of the planets as small colored symbols. With a few keystrokes, they can run time forward and watch the planets trace loops and curves, speeding up and slowing down against the background of the zodiac. Mars brightens as it approaches opposition and then seems to reverse course for a while before resuming its steady march eastward. This strange behavior, which puzzled ancient watchers, is simply a result of geometry, of the way two planets moving at different speeds around a central star appear from one another. Yet the language to describe it still carries the old flavor. Retrograde motion along the zodiac, a warrior god that seems to retreat, then advance again. On a different night, the astronomer brings friends up to the dome. Not scientists, people who simply like the idea of standing close to the sky. They pour hot tea, switch off the dome lights, and step outside. The band of the zodiac arches overhead, faintly brighter than the rest of the night, in places where countless unresolved stars and dust scatter sunlight. The friends ask which stars belong to which sign. The astronomer points, traces invisible lines, tells stories. There is the ram, low in the west. There the bull with the 7 sisters on his shoulder. There the twins. There the crab. There the lion. They talk about how the sun will pass through each realm in turn over the coming months, how ancient people built temples and myths around that slow progress. They also mention precession, the forgotten serpent bearer, the fact that the sun no longer enters the signs at the dates that newspapers claim. No one seems disappointed. If anything, the knowledge that the sky moves and systems can drift apart adds a kind of melancholy beauty. The zodiac is revealed not as a fixed wheel of absolute fate, but as a fragile agreement between human minds and a living sky. The constellations keep their places for now. The planets wander along the road that time and gravity have laid out for them. Above the whisper of conversation, the stars shine on, indifferent, patient, pouring their light into the eyes that look up in wonder and in curiosity and, sometimes, in hope that the old ring of animals and heroes still has more to tell. On the screen in the control room, the constellation of Orion looked simple, almost polite. A rough hourglass of white points with 3 bright stars in a straight line at the center. A pattern any child could find from a backyard or a city balcony. The astronomer tapped a key. The view changed. The stick figure of the hunter dissolved, and the telescope narrowed its gaze to a small blur that hung below the belt, in the place where storytellers once said his sword swung at his side. The blur became a storm. Suddenly the screen was full of cloud, not the grey folds that gather over mountain ridges, but a vast swirl of gas and dust glowing with its own light. Red and violet and ghostly white, dark fingers of cooler dust plunged into the brightness. At the heart of the cloud, a tight knot of stars blazed like a cluster of diamonds buried in luminous smoke. "This is the Orion Nebula," the astronomer said, and the small group of visitors in the dome leaned closer. In the old stories, Orion strode across the sky in finished form, a mighty hunter with bow in hand and a boast always ready on his tongue. Modern instruments reveal a different kind of tale in the same patch of sky. The nebula in his sword is a place of beginnings. It is a stellar nursery, a region where gravity has gathered cold gas into clumps that collapse and ignite. Inside those folds of red and violet, a new generation of stars is being born. To the naked eye, the nebula is only a faint fuzz, the sort of thing that you might notice only if you are already looking in the right direction. To a sensitive camera, it is an entire landscape. The hot young stars at its center pour out intense ultraviolet light that tears electrons from atoms in the surrounding gas. When those electrons fall back into place, the gas shines. What looks like smoke is in fact thin air on a colossal scale, so tenuous that you could pass your hand through it without feeling a thing, yet so vast that light takes years to cross it. The astronomer pointed to the heart of the glow, where 4 stars formed a small trapezoid. This little cluster, they explained, is called the trapezium. It is young on the scale of stellar ages, only a few million years old. The fierce radiation from these stars is sculpting the nebula, eroding some clouds into pillars and globules while triggering collapse in others. Somewhere in those folds, dusty disks may be circling newborn suns, the seeds of planets forming silently in the dark. Orion hangs over winter fields in the northern world, a guide for farmers and wanderers. Few of them knew that in the hunter's belt and sword, entire solar systems might be in the making. The stick figure that ancient eyes joined from bright points turns out to be stitched through with hidden depths. The telescope swung. The hunter slipped away. Another familiar pattern took his place. This one, higher in the sky, stretched out like a faint chain of stars beside the crooked W of Cassiopeia. Andromeda, the princess, the astronomer said. Saved from the monster by Perseus, set among the stars as a reward. They tapped another control. The view dove into the princess. A single smudge of light at the center of the constellations swelled and resolved into a great spiral, a whorl of countless stars wrapped around a central brightness. The Andromeda Galaxy. Here, myth becomes something smaller than what the lens reveals. In story, Andromeda is a single person, enchained and rescued. In the cold eye of astronomy, the constellation that bears her name contains a neighbor, wider and older than any city of the gods. The Andromeda Galaxy is the nearest large spiral galaxy beyond our own Milky Way, 2.5 million light-years distant. The pale mist that ancient observers noticed on very dark nights is the combined light of perhaps 1 trillion suns. The galaxy stretches far beyond the central glow visible to the eye. Huge arms of stars and gas curl around it. Dark lanes of dust cut through the disk like scars. Clusters of older stars swarm toward the halo. Around the galaxy drift small companions, dwarf galaxies that orbit like faint attendants. The astronomer told their visitors that when they looked at the image, they were seeing Andromeda as it was when early humans on Earth were just beginning to shape stone tools. The light had been flying through the emptiness all that time, just to end its journey on a telescope mirror and make an image in a mountain dome. Even more unsettling, the astronomer said, is the future. Andromeda and the Milky Way are moving toward one another. Their mutual gravity is drawing them together. In a few billion years, the two galaxies will interpenetrate, their stars weaving past one another in slow streams. Planetary systems will almost all be safe, because the distances between individual stars are vast, but the shapes of the galaxies will be torn and remade. Eventually, a single larger stellar island will form, its spiral arms gone, its stars mixed. From some vantage point within that new merged galaxy, the constellations we know now will be unrecognizable. The visitors fell quiet for a moment, as if listening for the faint sound of that future collision. The telescope moved again, this time to a more modest scene. On the chart, it was marked not with a cloud or a galaxy symbol, but with a small hexagon. The screen brightened with a dense swarm of blue-white stars. Some looked almost close enough to reach. The background sky between them was a deep velvet black. This was the Pleiades, in the shoulder of Taurus, the bull. In nearly every culture that could see these stars clearly, they earned a special name. The Greeks called them the Seven Sisters, children of the Titan Atlas. In one story, Orion pursued them across the earth until the gods took pity and set them in the sky, where he still follows with his belt and bow. In Japan, they are known as Subaru. Other peoples saw in them a clump of grains or a cluster of birds. Astronomers see in them an open cluster, born from the same cloud, bound loosely together as they drift through space. The stars of the Pleiades are young and hot, only around 100 million years old. Many are bright blue at visible wavelengths. A faint mist of reflection nebula wraps around some of them, made from dust that scatters the starlight and gives the cluster a soft sheen in long exposure photographs. The cluster is one of the nearest to Earth, a few hundred light years away. That distance has been measured with great care using the tiny shifts in apparent position that come as Earth moves around the Sun, a technique called parallax. Long ago, when astronomers drew the Pleiades as jewels in the hair of a goddess, they did not know how far away they were. Now we can state their distance with a confidence that would have seemed arrogant in earlier ages. Yet the emotional effect of looking at them from a dark field is still what it has always been. You lift your eyes, and there they are. A small, delicate swarm that seems both fragile and eternal. Other wonders hide in the zodiacal constellations and beyond. In the Archer, Sagittarius, there is a bright region near the plane of the Milky Way that amateurs simply call the lagoon. Through an eyepiece, it appears as a glowing patch with a handful of bright stars. In truth, it is another star-forming nebula, carved by storms of radiation and wind from newborn suns. Nearby lies the Trifid Nebula, a cloud split by dark lanes that give it a three-lobed appearance. In the constellation of Carina in the far southern sky, unseen from northern lands, an enormous nebula sprawls, larger and more turbulent than the one in Orion. Within it, a massive, unstable star once flared in an event so bright that 19th century observers thought a new star had appeared. That star, Eta Carinae, is close to the end of its life and may one day explode as a titanic supernova. To standing observers under that southern sky, Carina is just a figure, once part of a greater ship in Greek lore. To the astrophysicist, it is a laboratory where the lifetimes of the most massive stars can be watched in accelerated detail. Scattered through constellations are still older cities of stars. Globular clusters are compact swarms that hang in the halo of the Milky Way like lanterns. They contain hundreds of thousands of ancient stars crammed into a space only a few tens of light years across. One such cluster, called M13, glitters in the constellation of Hercules. Through a modest telescope, it looks like a ball of diamond dust, brighter in the center, thinning at the edges. The stars in these clusters are often among the oldest in the galaxy. When they were young, the Earth was not yet formed. In Virgo, the Maiden, lies a deep concentration of galaxies, the Virgo cluster. On a clear night under a dark sky, you might sweep that region with binoculars and see nothing but black. Through a large telescope and a very sensitive camera, hundreds of galaxies emerge, each one a world of stars. Their light has taken tens of millions of years to reach us. When astronomers map their positions and measure their motions, patterns appear that tell of gravity at work on truly colossal scales. Invisible matter, dark matter, holds the cluster together, tugging on galaxies like beads on an unseen string. Every constellation is like this, a simple pattern traced by human minds across the nearest bright dots, and behind that pattern layer after layer of depth. Clouds where stars are born, fields where they die, swarms where they keep one another company for billions of years. Great rivers of gas and dust, cold and waiting, whole cities of suns so far away that their light arrives as a faint smear, easily drowned by the glare of a street lamp. On the mountain, the astronomer stepped away from the console and let the dome drift half shut. The visitors shuffled out into the open air, their breath steaming. Over their heads, the familiar stick figures of Orion and Taurus and Cassiopeia hung in their usual places. No nebulae, no galaxies, no clusters, just pinpoints and faint haze. Yet now, armed with what they had seen on the screen, the sky seemed less simple. They knew that in the sword of the hunter, stars were being born, that in the chain of that distant princess, an entire galaxy was sliding through space on a long, slow collision course. That the little knot of light in the shoulder of the bull was a swarm of young suns that had risen from the same cloud and would one day drift apart. The constellations had become doorways, each bright outline an invitation to fall through into deeper space. Scattered through constellations are still older cities of stars. Globular clusters are compact swarms that hang in the halo of the Milky Way like lanterns. They contain hundreds of thousands of ancient stars crammed into a space only a few tens of light years across. One such cluster, called M13, glitters in the constellation of Hercules. Through a modest telescope, it looks like a ball of diamond dust, brighter in the center, thinning at the edges. The stars in these clusters are often among the oldest in the galaxy. When they were young, the Earth was not yet formed. In Virgo, the maiden, lies a deep concentration of galaxies, the Virgo cluster. On a clear night under a dark sky, you might sweep that region with binoculars and see nothing but black. Through a large telescope and a very sensitive camera, hundreds of galaxies emerge, each one a world of stars. Their light has taken tens of millions of years to reach us. When astronomers map their positions and measure their motions, patterns appear that tell of gravity at work on truly colossal scales. Invisible matter, dark matter, holds the cluster together, tugging on galaxies like beads on an unseen string. Every constellation is like this, a simple pattern traced by human minds across the nearest bright dots, and behind that pattern layer after layer of depth. Clouds where stars are born, fields where they die, swarms where they keep one another company for billions of years. Great rivers of gas and dust, cold and waiting, whole cities of suns so far away that their light arrives as a faint smear, easily drowned by the glare of a street lamp. On the mountain, the astronomer stepped away from the console and let the dome drift half shut. The visitors shuffled out into the open air, their breath steaming. Over their heads, the familiar stick figures of Orion and Taurus and Cassiopeia hung in their usual places. No nebulae, no galaxies, no clusters, just pinpoints and faint haze. Yet now, armed with what they had seen on the screen, the sky seemed less simple. They knew that in the sword of the hunter, stars were being born. That in the chain of that distant princess, an entire galaxy was sliding through space on a long, slow collision course. That the little knot of light in the shoulder of the bull was a swarm of young suns that had risen from the same cloud and would one day drift apart. The constellations had become doorways, each bright outline an invitation to fall through into deeper space. For many people in northern lands, this is the first constellation they learn. 7 bright stars form a ladle shape. In North America, many call it the Big Dipper. In Europe, it is the plough. In the old Greek tale, it is the hindquarters and tail of a bear that has been flung into the sky. The story says that a woman named Callisto was transformed into a bear and set among the stars to rescue her from the anger of a goddess. Her son, Arcus, became the little bear, Ursa Minor, whose tail ends in Polaris. The astronomer showed their guests how the 2 bright stars at the front of the Big Dipper bowl point almost directly to Polaris. Draw a line upward from them, and you come to that modest star, the present pole star. For centuries, sailors, travelers, and runaways seeking freedom have used that simple trick. The myth of a mother and child turned into bears is one way to remember the pattern. The fact that the bears never sink far below the horizon made them powerful guides. In truth, the stars of the Dipper are at very different distances. Dubhe, at the rim of the bowl, lies more than 100 light-years away. Merak is closer. The shape of the bear is a perspective effect. If you could fly among those suns, the pattern would dissolve. Yet from Earth at this epoch they form a reliable sign, and so the story holds. South again, the astronomer gestured toward a region that was mostly hidden behind the edge of the dome roof. They spoke instead of what lay there. Centaurus, a wide constellation in the southern sky, traces the body of a centaur, half man and half horse. In some stories, he is Chiron, the wise teacher of heroes. In his hand, he holds the Southern Cross, Crux, a small and brilliant constellation that hangs like a kite above southern seas. For navigators in the southern hemisphere, Crux serves as the northern bears do in the north. 2 bright stars nearby, Alpha and Beta Centauri, point to the cross. Lines extended from the cross itself point toward the south celestial pole, which has no bright star to mark it. On lonely oceans, sailors have lifted their eyes to this pattern as a way to find their south. The myth of a centaur and the shape of a cross became a compass in the hands of those who had nothing else. Within Centaurus lies another legend of science. One of its stars, Alpha Centauri, is a triple system that includes Proxima Centauri, the nearest star to our Sunday. It is invisible to the naked eye, but confirmed by careful measurement. In myth, the centaur carries wisdom. In astrophysics, the constellation that bears him carries the nearest known suns beyond our own, one of which has planets that may hold oceans and air. The astronomer let the silence gather for a moment. The visitors were beginning to see the pattern. Every hero in the sky has 2 lives, one in story, one in fact. Take Hercules, for instance, who stands near the summer triangle. To the Greeks, he was the strongest of all mortals, a man who wrestled lions and hydras and held up the heavens for a while in a bargain with a titan. In the sky, his figure is a modest scattering of stars that demands imagination to see. Yet within his outline, telescopes find the great globular cluster M13, a dense sphere of ancient stars packed together like grains of sand in a glass. Or Cygnus, the swan, whose cross shape glides along the Milky Way. In some tales, it is Zeus in disguise. In others, it is the soul of a musician. Modern instruments reveal that along the body of that swan lies a dark cleft in the Milky Way, the Cygnus Rift, where clouds of dust obscure the light of countless distant stars. Within the same constellation, astronomers found one of the first convincing black hole candidates, a source of X-rays called Cygnus X1, a bird from myth, a river of dust, a collapsed star that bends space. All these inhabit the same patch of sky. The astronomer looked back at their guests. The constellations will always be more than one thing at once, they said. For some people, they are characters in an old drama. For others, they are signposts and tools. For us, they are also markers for places where physics does something interesting. None of those readings cancels the others. They sit together like layers of paint on the same canvas. Far above, Orion was rising again, his belt clear, his sword faint. The hunter was still boasting in one story, still sheltering newborn stars in another. The queen still turned in her slow punishment. The bears still circled. The centaur still held his cross over invisible southern seas. Or Cygnus, the swan, whose cross shape glides along the Milky Way. In some tales, it is Zeus in disguise. In others, it is the soul of a musician. Modern instruments reveal that along the body of that swan lies a dark cleft in the Milky Way, the Cygnus Rift, where clouds of dust obscure the light of countless distant stars. Within the same constellation, astronomers found one of the first convincing black hole candidates, a source of X-rays called Cygnus X1, a bird from myth, a river of dust, a collapsed star that bends space. All these inhabit the same patch of sky. The astronomer looked back at their guests. The constellations will always be more than one thing at once, they said. For some people, they are characters in an old drama. For others, they are signposts and tools. For us, they are also markers for places where physics does something interesting. None of those readings cancels the others. They sit together like layers of paint on the same canvas. Far above, Orion was rising again, his belt clear, his sword faint. The hunter was still boasting in one story, still sheltering newborn stars in another. The queen still turned in her slow punishment. The bears still circled. The centaur still held his cross over invisible southern seas. The sea at night is a kind of dark that land rarely knows. There are no walls to catch the light of a lantern, no trees to throw back the glow. The ship is a small island of wood and rope and human breath, floating on something that feels infinite. Above it hangs another infinity. For a sailor alone on the midnight watch, the sky is not decoration. It is the only map that never sinks. Imagine an old wooden vessel, the sails straining softly in a steady wind. The creak of the hull and the muted slap of waves on plank are the only sounds. The navigator steps out from the dim cabin and looks up. He does not see random stars. His mind is already tracing Old Bear and Little Bear, the crooked W of the Queen, the belt of the hunter. Somewhere ahead on this invisible sphere lies the port he seeks. Somewhere behind him lies the shore he left. Between them is only water and the patterns of the sky. Long before compass needles and satellite signals, people learned that stars rise and set with disciplined regularity. They saw that some never rise above the horizon, some never set, and some skim close to the edge of the world. They noticed that the height of certain stars above the sea changed as they sailed north or south. Out of those quiet observations, a new use for constellations grew. The figures in the sky stopped being only myths and became instruments. Bears and kings and queens turned into compasses and rulers. In the northern world, one star has been especially useful. Polaris, the North Star, sits very near the point in the sky where the axis of the Earth points. For an observer at any northern latitude, Polaris appears almost fixed, while the rest of the sky turns around it. The angle between Polaris and the horizon tells you your latitude. If it stands 30 degrees above the sea, you are at about 30 degrees north. If it stands 20, you are farther south. At the pole, it would tower straight overhead. The Greeks told stories about the bears that circle that unmoving point. Ursa Major, the Great Bear, and Ursa Minor, the Little Bear, were once humans in their legends, transformed and flung into the sky. Those same shapes were also practical guides. The two stars at the front of the bowl of the Big Dipper, which is part of Ursa Major, point straight to Polaris in the tail of the Little Bear. A navigator who can find the ladle can find the pole. A navigator who can find the pole can keep a course through long nights and storm-confused mornings. Classical writers hint at how this knowledge spread. There is a tale that Greek sailors once steered by the brighter Great Bear, while Phoenician sailors used the fainter Little Bear for greater precision, because Ursa Minor sits closer to the true pole. Whether the story is literally true or not, it records something real about the progress of navigation. Sailors went from rough guesses to finer measurements, always guided by the same family of stars. Of course, Polaris has not always been the pole star, and will not remain so. Precession slowly shifts the point in the sky where Earth's axis aims. Thousands of years ago, a different star, Thuban, in the constellation Draco, lay closer to the pole. The pyramids at Giza may align with stars that no longer mark the same part of the sky. In some future age, a bright star in Cygnus or Lyra may take the place of Polaris. For now, in this chapter of human history, the Little Bear holds that central honor, and sailors and hikers and lost children can still trust it. In the south, the problem is harder. There is no bright star near the celestial pole. For Western navigators who sailed those waters, the answer came from another constellation altogether. Crux, the Southern Cross, hangs like an arrow over the southern sea. Its four main stars form a small but striking cross. Nearby, two bright stars in Centaurus, Alpha and Beta Centauri, point toward it like lanterns for the eye. If you extend the long axis of the cross about 4.5 times its length, you arrive near the south celestial pole. From there, a vertical line dropped down to the horizon marks true south. It is a simple geometric trick, but it depends on knowing the constellation well enough to spot it. European explorers of the 15th and 16th centuries learned this from long nights on new oceans. Indigenous navigators in the southern hemisphere, from Australia to the islands of the Pacific, had their own elaborate ways of reading the same stars. ways that tied Crux and its neighbors into stories and songs that fixed bearings in the mind. The age of exploration did more than send ships into unknown waters. It also sent eyes into unknown sky. Ptolemy, who wrote in Alexandria in the 2nd century of the Common Era, knew only the constellations visible from his latitude. His list of 48 constellations covers much of the northern and equatorial heavens but leaves the deep southern sky mostly blank. When European sailors began to cross the equator regularly and push far into the southern hemisphere, they saw stars that were never recorded in Greek poems. Clouds of hazy light that we now call the Magellanic Clouds. A brighter, denser stretch of the Milky Way. New patterns of bright points begging for stories. Cartographers and astronomers on shore took reports from these voyages and began to stitch those new stars into the old fabric. In the late 16th century, a Dutch cartographer named Petrus Plancius used observations by navigators Pieter Kieser and Frederick de Houtman to create a series of new constellations for the southern sky. Dorado, the swordfish; Volans, the flying fish; Indus, the figure of an indigenous person; Pavo, the peacock. These shapes were not born in Greek mythology, but in the roots and concerns of ocean voyages. They mapped the places where new lands and peoples had entered European awareness. A few decades later, in 1609, a German lawyer and skywatcher, Johann Bayer, published an influential star atlas called Uranometria. It was the first atlas to cover the entire celestial sphere from pole to pole. Bayer included the old Ptolemaic constellations and many of the new southern ones, and introduced the system of Greek letters that still mark the brighter stars in each group. The atlas served both practical navigation and the growing science of positional astronomy. A captain with a sextant and a copy of such a map could measure the height of known stars and compare their positions to tables, narrowing down his own location on the ocean. In the 18th century, a French astronomer named Nicolas Louis de Lacaille spent years at the Cape of Good Hope, cataloguing thousands of stars in the southern sky from the safety of a stone observatory. He invented still more constellations, many named after scientific instruments and tools: telescope, microscope, the air pump, the compass, the square. In doing so, he etched the culture of his own age into the sky as clearly as earlier storytellers had carved their gods and beasts. The southern heavens became a museum of the scientific revolution, hanging above ships guided by sextants and chronometers. Navigation at sea depended on more than knowing names, of course. It was a craft of angles and times. To find latitude, a navigator measured the height of Polaris above the horizon, or, in southern waters, the noon height of the sun at its highest point in the sky. To find longitude, which was a far harder problem, they needed an accurate clock so that the local time could be compared to a reference time at a known meridian. For a long time, sailors tried to use the moon and certain stars to estimate that difference. Later, after the work of clockmaker John Harrison, ships carried marine chronometers, intricate pendulum-free clocks that could keep time across long ocean voyages. Yet even with good clocks and fine instruments, none of it worked without the stars. The tables in books called nautical almanacs gave predicted positions for the sun, moon, planets, and selected bright stars against the backdrop of constellations. By sighting a star in a known constellation and comparing its observed angle to the predicted one, a navigator could draw a line on a chart. 2 or 3 of those lines, from different stars, would cross at a point that was, with luck and skill, very close to the true position of the ship. In that sense, the constellations became a lattice of checkpoints on a great invisible grid. A star in Virgo, another in Crux, another in Orion, each with its own precise coordinates that changed slowly with precession, but were stable enough over a human lifetime. Where storytellers saw goddesses and beasts, navigators saw landmarks on a road made of nothing but light. The practice did not end when the age of sail gave way to steam and steel. Even in the 20th century and beyond, navies trained officers in celestial navigation. Radio and later satellite signals can fail or be jammed. The positions of bright stars and the patterns of constellations do not depend on transmissions from Earth. They come straight from the universe. Climb higher now, above the atmosphere, where the air thins and the sea becomes a curve of blue. Spacecraft and satellites carry their own kind of navigator. Many have instruments called star trackers. These are cameras that continually take images of the sky and compare the patterns of bright points against a stored catalogue. It is the same task an ancient sailor performed with his eyes and memory and a rough drawing on a scrap of parchment. The machine does it faster and with more precision, but the principle is the same. Recognize a pattern, match it to a map, and then determine where and how you are oriented. The star catalogues used by these instruments do not speak of Orion the Hunter or Cassiopeia the Queen. They list stars under clinical labels, with numbers and magnitudes and coordinates. Yet the regions of sky those stars occupy are still divided under the same old names decided by the International Astronomical Union in the early 20th century. When engineers plan a space telescope survey, they assign chunks of sky by constellation. Observers speak of a deep field in Fornax or a cluster study in Coma Berenices. The Queen, who once boasted of her hair, now lends that hair to a region of faint galaxies and intergalactic gas. From the deck of a Phoenician ship to the bridge of a modern icebreaker to the control rooms of satellites, the constellations have served as a quiet, continuous framework. They are the grid that does not rust. The line from a sailor's eye to Polaris and from a star tracker sensor to a nameless sequence in a catalogue is the same line, stretched over centuries. On the mountain where our astronomer stands, the visitors who listen to tales of Orion and Perseus can, if they wish, hold a sextant and learn to measure angles. They can raise it to the sky, catch a star in its narrow frame, and feel for a moment what it is like to let light and time tell them where in the world they are. The constellations above them are more than stories. They are tools and teachers, still guiding travelers across oceans of water and deep into oceans of space. On some nights, the sky feels like a painting. On others, it reveals itself as something that is moving all the time. A slow and patient dance that ignores the scale of human days. The mountain observatory had learned both faces well. There were quiet evenings when the constellations seemed fixed in their familiar places, and there were hours near dawn when the rotation of the Earth made the stars drift in a way that even an untrained eye could feel. The astronomer liked those hours best. The visitors had gone, the telescope was parked, the dome's slit was a bright wound cut into the darkness. The clock in the control room murmured, marking out seconds with mechanical indifference. Outside, the sky turned with the great steadiness of a wheel. If you watch long enough, the astronomer told the night, you can see that nothing in this place is truly still. The most obvious motion is the daily turning of the sky. We grow up with it, so it does not seem strange. Stars rise in the east, reach a highest point, and set in the west, pulled along by the spin of the planet. To ancient watchers, this motion suggested a solid sphere turning around the Earth. They pictured the constellations nailed to a crystalline shell that revolved once every 24 hours. The reality is both simpler and more profound. The Earth spins like a top, one full rotation in a little less than a day, and the stars only seem to move because we turn beneath them. A person near the equator is carried around that axis at a speed of more than 1,000 miles per hour, and yet feels nothing. The only hint is the sweep of constellations across the sky. There is another layer of motion. The Earth circles the Sun once every year. That slow revolution means that the night sky changes with the seasons. Orion rules the evenings of winter and is lost in the glare of the sun by summer. Scorpius and Sagittarius crowd the southern sky in the warm months and vanish behind the sun during the cold. The zodiac is simply the trace of that yearly circle, the line where the plane of Earth's orbit cuts the celestial sphere. Far more subtle is the sway of the axis itself. The planet does not keep its spin perfectly upright. Over about 26,000 years, the direction in which the axis points drifts in a slow wobble, called precession. Seen from outside, the line drawn by the North Pole would trace a wide circle in the sky, so that the title of pole star moves from one candidate to another over long ages. The constellations that wheel around that pole change as well. There was a time when different stars held the central place. There will be a time when Polaris is only one more light in the northern crowd, and some other star marks true north. The astronomer stood on the frost-rimmed platform and thought of ancient builders who aligned temples and stones with care, aiming shafts so that special stars would rise in sight at certain times. Those alignments were perfect in their day. Now, centuries or millennia later, they point slightly aside, not because the stones failed, but because the sky itself has shifted. The heavens have turned one face away and shown another. Beyond precession, there is yet another motion, so slow that it only becomes obvious through precise measurement and patient comparison. Each star moves through the galaxy on its own path, guided by the combined gravity of everything around it. To our eyes, over a single lifetime, most stars seem fixed in their patterns. A few have noticeably large proper motion. Barnard's star in the constellation of Ophiuchus creeps across the sky at a rate that careful observers can map in a human span of years. But for the most part, the dance of the stars is revealed only when astronomers compare photographs taken decades apart, or when they run computer models forward many thousands of years. In those models, the constellations warp and fray. The belt of Orion lengthens as one star slides away faster than the others. The Big Dipper collapses and elongates. The W of Cassiopeia opens into a crooked arc. The heroic figures and careful patterns that humans found in the sky turn into shapes that would be unrecognizable to any shepherd from Mesopotamia or any sailor from the Age of Sail. It is a reminder that constellations are local customs in time as well as in culture. They are patterns that make sense for a few tens of thousands of years at most. Before that, and after that, a different mind would find different shapes. The hunter, the queen, the great bear, the Southern Cross, all are temporary agreements between star positions and human imagination. Even the galaxy that holds those stars is not still. The Milky Way itself spins, a vast disk of gas and dust and suns that turns around a central concentration of mass. Near that center waits a dark object, a black hole with a mass millions of times that of the Sunday. The Sun and its planets orbit that distant hub once every 200 million years or so. During that long journey, the night sky above our world changes many times. Constellations come and go. Clouds of gas that once were dark may briefly blaze with newborn stars and then fade. Clusters drift from their nurseries and dissolve. From the perspective of that galactic timescale, humanity has barely looked up at all. All the stories about bears and lions and princesses and heroes fit into a blink of the galactic eye. The constellations are a fleeting decoration on one world, in one arm of one spiral. Yet for the people who first told those tales, they felt eternal. Even now, with our knowledge of stellar motion and galactic dynamics, it is hard to look at the familiar patterns and not feel that they have always been and will always be. The astronomer thought of other skies. Worlds orbit other stars. Some circle red suns, some white, some golden like our own. On those planets, other minds, if they exist, would look up and see different patterns. Perhaps they join bright points to make their own hunters and queens. Perhaps they see shapes we would never imagine. Perhaps the sky for them is only physics, an array of sources that they chart without any need for myth. Or perhaps they are more inclined to story than we are, and their constellations would fill an entire library. What we do know is that the urge to find patterns is not a trivial part of human nature. It is a survival trait. It is the same instinct that lets a hunter read tracks in mud and a healer notice that a certain plant eases a certain pain. When that instinct is turned upward, it takes the raw scatter of stars and makes meaning. Bears to steer by, a scorpion to warn of the season, a ring of animals to mark the path of the Sunday. Astrology was one way that people tried to press that meaning further, to say not only that the stars could guide a ship, but that they could shape the soul. The great ring of the zodiac became not just a circle in the sky, but a wheel of fate. Kings consulted astrologers about battles. Merchants worried over their charts. Families checked the positions of planets before arranging marriages. Modern science has taken those claims apart. Careful studies have found no evidence that the position of Mars or Jupiter in a constellation at the moment of birth has anything to do with a person's character or destiny. We know now that the gravitational pull of those planets on a newborn is negligible compared to that of the doctor who lifts the infant. The sky does influence us, but through light and warmth and the particle storms of the sun, not through symbolic resonance. Yet something of that older outlook lingers in a quieter way. When people say they are a lion or a crab or a set of twins because of their birth date, they are reaching for a story to place themselves in. It may not be a story grounded in physics, but it uses the same raw material that astronomers use. The constellations give us a shared vocabulary, When you say that Orion has risen, most who know the sky picture the same three belt stars and the same spread shoulders. When you say that the seven sisters have risen from the edge of the world, many minds see that small blue cluster in the shoulder of the bull. The astronomer did not mind that double use. It was possible, they thought, to hold both ideas at once. The sky is a place of measurable objects whose motions and properties can be studied with instruments. It is also a canvas where human beings project meaning. The first does not cancel the second. Instead, they intertwine. A person who comes to the observatory because they love the romance of star signs might leave with a new understanding of stellar evolution. A person who arrives with a head full of equations may, after a long night of data, step outside and suddenly feel the weight of an old myth in the angle of a constellation. The dome motors whirred softly as the slit closed. The telescope was safe for the coming day. The astronomer walked down the gravel path to where the mountain fell away into darkness. The eastern horizon was still black, but a paler band hinted at the sun waiting below. Above, the stars were beginning to lose their hard edges. This is the moment, the astronomer thought, when the two worlds touch. The stars that had guided farmers and sailors and dreamers all night would soon fade into blue. The sun, one more star among many, would flood the sky and hide its brothers and sisters from view. The constellations would not vanish. They would wait, printed behind the light, ready to emerge again when the earth turned and carried this place back into shadow. You stand somewhere on the surface of that turning world. You have your own share of this dance. Every time you look up at night and recognize even a single pattern, you are joining in a practice that spans cultures and centuries. You are using ancient names to label nuclear furnaces. You are setting small human stories against distances that light takes years and millennia to cross. The great ballet goes on whether you are watching or not. Stars swing around the galactic center. Galaxies tug at one another in long embraces. Clusters fall inward and scatter. Nebulae flare with new light and then thin back into darkness. Constellations stretch and twist. Bears and hunters and princesses drift slowly into new shapes. For a brief time, in this thin slice of history, they look the way they do now. The hunter strides, the bear wheels, the cross hangs over southern seas, the queen rides her turning throne. The patterns of myth and the maps of science rest on top of the same moving sky. When you step outside on some quiet night, far from clocks and screens and the noise of the day, you will find them waiting, the hunter on his march, the bear in her slow circle, the ring of animals along the path of the sun, the faint ghosts of queens and ships and swans. They are only stars, and yet also every story that people have ever told about the sky. If you wish, let the porch light go dark, tilt your head back, and give them a moment. The constellations will not answer, but they will keep you company. They have been doing that for a very long time. Good night.